So today we're going to address the remaining two topics from this class. One is looking at the pricing function of the supply chain, and the other one we're going to look at an emerging concern in the past years, that is the concern of sustainability of supply chains. So in next class, we're going to do our last case study of the semester, which is to look at a very interesting case where a company is applying these new technologies such as blockchain, AI, machine vision to explore some of the new opportunities. Okay, so the last function we have yet to talk about in the supply chain is pricing function. So in pricing, a lot of times this is in the context of revenue management. So we're going to look at how pricing, how revenue management can help supply chain increase its profits, and describe various types of pricing mechanisms such as dynamic pricing and overbooking and differentiated pricing. And then we're going to look at how we're going to skip peak pricing, off-peak discounts, because it was covered before when we talked about inventory. And then we're going to look at how we can combine long-term contract and spot purchases and increasing profits. Finally, we're going to look at some negative consequences of revenue management in practice. So revenue management is a very general term, which means we're using the function of pricing to increase profit generated from a given supply of supply chain assets. So supply chain assets refers to either capacity, like production or service capacity, or inventory of products. And basically we traditionally firms would change the availability of assets, either capacity or inventory, to match supply with demand, which allows us to capture as much profit as possible. And revenue management is this a deeper dive into the pricing function to help us differentiate and capture more value from different customer segments based on the time of consumption of the product or service, and by adjusting the availability of our product or capacity with the ultimate goal of increasing supply chain profits. So it's still the same goal, and just now it's achieved by adjusting price rather than capacity or inventory. So revenue management is particularly useful if one of these conditions holds in a particular company. One is that we are facing different customer segments, right? So different people would place different values on different attributes of our products. And the second condition is the product is perishable or product wastage occurs. Right? So basically this means the value of the product will diminish over time. and it may become completely useless or have zero value after a certain period of time. Third condition is when demand is highly seasonal or have a lot of peaks and valleys. And fourth condition is that we have a mixture of markets where the product is sold. We may be selling the product in bulk in a wholesale market, and we can also be selling the product on the spot market, which means we're going to deliver the products immediately and possibly make a higher profit margin. So you can think of it as wholesale versus retail. So what are the potential advantages of revenue management? One is a change in pricing is a lot of times much easier to manipulate than changing the production capacity or changing the amount of inventory held. So pricing is sometimes more accessible lever to play with. And also, by differentiating, a lot of times when we do revenue management, the basic idea is differentiating customers. So however we are differentiating customers, if we do this appropriately, it will allow us to serve each segment of customers better. Right, so especially high-value customers who are willing to pay more for certain attributes of the product, by differentiating the pricing strategy, we can better serve these customers. And on the other hand, the more price-sensitive customers are able to purchase the products with a lower price. So everybody may be better off with a revenue management strategy. So let's look at the basic idea behind the value for differentiated pricing. So let's say we're going to look at this very simple demand function form. Right, so we're assuming a linear demand function where demand is decreasing with the product price. So you can see here, if we charge a price of, say, $2, then we'll end up with 6,000 units of demand. Right. If we charge a price of $3.5, then we may end up with a demand of 3,000. So there are basically the amount of customers that are captured in this segment are customers who are willing to pay more than $2. $2. Yep. And so say if we have to just use a very simple pricing strategy to charge a single price for everybody, then what we do is to calculate the profit function, right? So the profit of this company is equal to demand multiplied by, say, the profit margin, or so let's say assume for simplicity that the cost of the product is 0. So then let's just say this is equal to P times D, and we maximize this profit by choosing P. And this can be simply done by taking a derivative of this function. So then we'll get that the optimal price is equal to 2.5, as shown on this figure here. And the resulting demand, based on this single price, is 5,000. And the profit or revenue, let me just write revenue instead. The corresponding revenue is equal to $12,500. Okay, so, and we can do better than that simply by offering two prices. Right, so we're going to charge $2 for people who are price sensitive and charge $3.5 for those who are willing to pay $3.5. And the extra revenue that the company can extract is significant. So the total revenue for this case is $16,500, and this is because the whole area that's covered here by the two different prices is larger than this area. Right, we're able to better match demand with supply and extract more value from the people who are willing to pay more. And so in general, differentiated pricing is the basis of revenue management, and the goal is it increases the total profit compared to a very simple single price strategy. But in implementation, the real issue is how do we actually design these two different prices, right? There are some issues that we need to consider. One, we want to separate the different segments of customers, right? So how do we do that? One, use demand. Okay, how do you use demand?
When the demand is high, we can price it differently, like based on the consumption market. So if the demand is low, then we can keep it higher. If demand is higher, we can make it lower just to be competition. And
but if we do it, the profit won't be increased or decreased. It would lie in the same thing, right? As you said, like if the demand is high, you would actually decrease the cost of the product. If the demand is low, you would increase the price, which is actually balanced.
So high-low pricing is one way to do revenue management. it's basically, you can think of it as, and we discussed this when we're talking about inventory management, right? So if your sales strategy is effective when the demand is high, then it's better to do sales promotions when the demand is high versus when demand is low. And this is based on how your customer responds to your pricing strategy, right? But it doesn't have to be just based on peak or non-peak demand, right? So basically, we know that customers value different things, and some people place a higher value on certain attributes of the product than others. So basically, we would like to somehow distill that value in our pricing menu. So, for example, right, when airlines do revenue management a lot, so we have, for example, business travelers who would like their business schedules may be subject to change, and they're willing to pay for this flexibility of being able to book very close to their travel date. The opposite side is our leisure, like you and I, who want to go for a vacation, and we would like to pay for at least amount of money as possible, and to be able to extract that low price, I'm saying I have to book, way ahead of time, because price is cheaper ahead of time. And the reason why price is cheaper ahead of time is because airline does revenue management. And so this is differentiating customer segments based on their evaluation for time, right, and for the price of the tickets. The other thing is, so how can firms control demand such that the lower paying segment does not utilize the entire availability?
Could you please explain the previous thing, like differential pricing for multiple customer segments? Like, how does the segment differentiate? The graph thing. The graph which was in the previous slide.
Oh, this one?
The previous one. This one is like the maximum revenue. What is the demand? What's the D, which is 10,000 minus 2,000 P?
Yeah. So this is 5,000 is equal to 10,000 minus 2,000 times 2.5. This scenario is a single price, and even though customers are placing different valuations on the product, we don't differentiate the product. The only dimension that the product is evaluated on is the price,
Yes.
right? So in this case, we are not able to differentiate customer segments.
Okay.
In order to differentiate customer segments, we have to introduce another dimension. In the airline case, it's time. Okay, so this sort of answers the first question: how do we differentiate the products for different segments? And then the second question that we need to answer in revenue management is, how do we make sure that the lower paying segment does not utilize the entire availability of the asset? Right, so basically, this is to say, how do we make sure on the plane not all the seats are purchased by, leisure travelers? How do we do that?
Introduce economy class
promotions.
Yep. Right. So the fact that airlines introduce different classes of seats is to basically reserve a certain amount of seats for people who are willing to pay more and they want to make their purchase maybe at a later date. So in actually designing the pricing strategies under revenue management when we're facing multiple customer segments is one, how much to charge and how much to charge for each segment, and then how much capacity should be allocated to each customer segment. So we're going to look at a simple way to model this problem when we are facing different customer segments. So let's say we did a lot of data analysis, we understood our customers, and we know that there are K segments that of customers we're facing. And for each segment I, we know the demand curve for this segment. And let's say it's also represented by a simple linear demand curve equal to AI minus BI times PI, where PI is the price we charge, particularly for this segment. So as the supplier of this product, basically we can try to maximize the total profit from each segment. Right, so the profit is equal to profit margin times the demand from this segment. So again, this is a quadratic function of PI. So we can take a first order derivative of this profit function and calculate the optimal price. All right. So the optimal price for each product, for each customer segment, I should say, is simply this much. And this, you can see each of this price for different customer segments are independent of one another. Right, so basically we're just looking at our different customer segments separately and try to maximize what we can generate from them separately. But oftentimes we cannot completely separate them, right? The reason being what?
Demand is related to each other. Supply is
Could be demand related to each other. What else? For example, in the airline case, how does one segment's pricing strategy affect the other segment? How does economy class pricing affect first class pricing? First class, pricing.
Should it be more or it should be less? Like it should be. If it's very less, then people will prefer that. At the same time, for value proportion for money, right?
Mm-hmm.
So
Right. So in this extreme case where we charge the same price for,
First
economy
class.
and first class, why would anybody buy economy? Right? Given that you have more flexibility than economy class. So the reason why we cannot separately consider the pricing for different segments in most cases is possibly we could have demand correlations between different segments, but more importantly that we have limited capacity, right? So the pricing of one segment determines the demand from that segment, and therefore determines how much of my capacity is going to be consumed by that segment. So it also determines how much capacity is left for other segments, right? So once we add the capacity constraints, we should anticipate that the prices will depend on one another. So formally, we can formulate this as a optimization problem. Right. What we're trying to do is to maximize the total profit generated from all the segments. But we're subject to constraints, which is the total demand satisfied from our pricing strategy should not exceed our capacity. And of course, we would like to have the demand greater than zero for each segment. So this Q for in our airline example would be the total number of seats, right? Okay, so let's look at an example. So let's say we have two customer segments, and each of them have different demand curves, right? And then looking at these demand curves, who are more price sensitive? One or two? Two. Yeah, with the same price, demand from two would be smaller than one. And say the production cost is $10 per product. So let's say scenario one, we do a simple differentiated price without considering the capacity constraint. So this is to basically we can use our formula for the optimal price that are independent of one another. So P1 would be 5,000 divided by 2 times 20 plus 10 divided by 2 equal to 130. And P2 would be divided by 2 times 40. So 67.50. We can see for the price sensitive segments we charge a lower price. And correspondingly, we can calculate the demand from each segment. D1 would be equal to 2,400 and D2 equals 2,300. So these are just simply substituting the P values into the demand function. the total profit is equal to $130 minus 10 times D1 plus 67.5 minus 10 times 2300 equals 420250. So we can show that this is much more advantageous than if we were to charge the same price for both segments. In which case, we would calculate the total profit function. Which is equal to P, now a common P for the total demand. Right, so D1 plus D2. And the optimal common price is then $88.33. So again, if you plug this in to the demand functions, D1 would be 3233.4 and D2 is 1466.8. Alright, so now with this same price, demand from the first segment is higher, demand from the second segment is lower. Right? Now, because the common price is between the previous two prices, and the price sensitive customers are willing to pay less, so the demand is less. And in this case, our total profit
Would decrease.
$368,167, much lower than before. Alternatively, in a more realistic scenario, is we can use differentiated price, but we have limited capacity. So basically, now we're trying to maximize the profit under differentiated price. Subject to capacity constraints, which is the total demand should be less than or equal to our total capacity, and the two demands should be 5,000 minus 20 P1 should be greater than 0, and 5,000 minus 40 P2 should also be greater than or equal to 0. And of course, if you want to be robust, P1, P2 are also non-negative. So again, like this can be done in Excel Solver. So this is the example, right? We have two segments of customers, each we charge a different price. So we can make this to be 0, 0 to begin with, and demand is calculated using the linear demand functions, and then we sum up these two demands to get the total demand satisfied. Profit from each segment can also be calculated by multiplying profit margin with demand, and then summing up the total profit in this cell. And our production capacity in this case is 4,000 units. So go to our solver. The objective is to maximize total profit and changing product sales, which are our prices, so these two cells, and subject to the constraints. One is that the demands should be greater than or equal to 0. The other one is the total demand should be less than or equal to capacity. And I also check the variables are non-negative, so prices are non-negative. This program is nonlinear, so we're using GRG nonlinear. Solve, and here give us the price, and this is the profit. So we can see that by adding a product capacity, the profit is decreased, and the capacity, the demand reduction in the first segment is smaller than the second segment because we want to give more capacity to the more valuable product customers, and it's still a higher profit than if we were to charge a single price. So then, what if there is uncertainty in what we're facing? And this is going to be optional, so it won't appear in the exam. So it's often the case that there is enough demand from the lower price segment to use up the entire capacity. So for example, in our plane case, okay, the leisure customers may just occupy all the seats available if we let them. So we are going to determine how much the capacity to allocate to each segment of customer, the business class or versus economy class. And the basic trade-off is between committing to an order from the lower price buyer in an earlier time, or should we wait for higher value customers come along in a later stage by reserving this seat. So basically we're trading between spoilage and spill. Right, so if we reserve too much seats for first class or business class customers, then these seats may become unfilled in the end, so we waste this capacity. And the other side is spill. So basically, then if we gave away too much seats in the beginning to lower seats customers, then higher value customers might arrive later on, but no seats are available. So mathematically, this can also be illustrated similarly as what we were doing before when we were trying to determine the appropriate service level, the appropriate order quantity when we're facing uncertain demand. So let's say we have a high value customers and low value customers, and we charge PL to for low value buyers, and PH is the price for high value buyers. And we make the assumption that the demand for the higher price segment is normally distributed. With a certain mean that's DH and a standard deviation sigma H. And say up front we're going to reserve CH amount of capacity. Then the expected marginal revenue from reserving more capacity is this term. So this is the expected marginal revenue from reserving more capacity. Basically equal to the probability that we have more demand than reserved times the profit, the revenue that's going to be generated from this additional demand fulfilled. So the CH, the amount of capacity reserved, should be chosen such that we're balancing off the spillage and spill and spoilage. Right, so basically we want the marginal revenue from higher price segment equal to the current marginal value from the lower price segment, which is to say this is equal to PL. From this, we can get this probability should be equal to PL divided by PH. So then, apply the inverse function of this normal CDF we can calculate CH value. Okay, so this is the same formula we use for calculating optimal order quantity and optimal service level. So let's look at a quick example. Let's say we have two segments, segments A and B, and using our previous example data, so for segment A we're charging $3.5, for segment B we're charging $2, and the average demand. So now segment A is our higher value customers, and we're unsure about their demand. So we only know the demand average is 3,000, and the standard deviation is 1,000. So now the question is, how much of the available capacity should be reserved for segment A, given our demand distribution forecast? So using the formula we just derived, basically this term is equal to the inverse normal function for 1 minus PB divided by PA, and given the demand distribution. And if we were to have an even higher value customer segment for segment A, so this is 1, so this is scenario 1. Scenario 2, PA is equal to $5. Then we can see we want to reserve even more capacity for the higher value customer segment. So we can see that with revenue management, we're able to reserve capacity for higher value segment customers and therefore improve their service level. And generally, how this is done is by creating different versions of a product to target at different segments. And what are some general tactics used in practice for creating different customer segments? One is to separate them on some service dimension. The most commonly used one is response time. And the other one is charge different prices based on the value assigned by each segment. And so it's important to forecast demand at different for each customer segment, because we want to understand how customers react to prices and other dimensions differently. And that will allow us to be better able to capture the values in customer demand. And an important thing, because oftentimes lower value customers are paying upfront. So it's very important for us to reserve capacity for higher value customers when they arrive at a later stage. And we just look at a model for determining what is the appropriate capacity to reserve. Okay, so that is the general differentiated pricing strategy. The other types of revenue management strategies are going to be similar to differentiated pricing. It's what dimension basically we're differentiating price on. So, for example, one can look at dynamic pricing. And so dynamic pricing is applicable for when the product is perishable. So perishable can mean literal perishability, like pharmaceutical items, food items that spoil over a certain amount of time. It can also mean products with a very small life cycle, right? So electronic devices, high-tech items, fashion items are considered to be perishable assets. So in dealing with perishable assets revenue management, there are two basic approaches. One is dynamic pricing, and one is overbooking. And so dynamic pricing is basically the price is varied based on the time period. And overbooking is to say I'm basically overselling the product ahead of time and accounting for the fact that some of the orders are going to be canceled at a later stage. So let's look at dynamic pricing first. The dynamic pricing can also be a very powerful tool for increasing profits, and this is based on the condition that the customer's sensitivity to price would change over different periods in a selling season. So for example, when we're talking about fashion products, right, there are people who value very trendy items. They want to pay for the products immediately as they get released. So these people generally pay higher prices. And as the time goes on, the fashion product loses its value because it deviates farther away from current trend. So the more price-sensitive customers will then arrive to purchase the product. Then we will have this very similar expression or model for dynamic pricing as differentiated pricing. So before we have different segments, K segments. Now we have basically K periods in the selling season. And based on the given period, the arriving customers may have different characteristics and they have different price sensitivities. So then we can again characterize the demand for a given period I as a linear function decreasing in the price of the period. And the idea is we're going to charge different prices based on what time period it is. And again, we're maximizing the total profit generated over the whole selling season by choosing the selling prices in each period. And we want to make sure that the whole demand that's satisfied during the selling season is less than what I ordered or how much my capacity is upfront. And again, demand for each period should be non-negative as well. So a simple example is when demand, we have maybe 3 months in a selling season, right? And then each selling season has a different demand function. So you can see as time progresses, the demand is more and more sensitive to price. And we're maximizing the total profit subject to the demand being less than capacity and all the demand are greater than 0. Now, once this is established, right, and this can be solved in Excel exactly the same way as what we did before. And as we solve the revenue management or pricing decisions for dynamic pricing decisions for this problem, then we can go back to look at how much should we purchase in the beginning, or how much capacity should we reserve in the beginning. So, for example, for the fashion retailer, this is how many clothing items to buy at the beginning of the selling season so that my profit is maximized. Given that I have the flexibility to design my dynamic pricing strategy. So now my decision is to maximize the profit, but I'm accounting for the investment that I put into the inventory or the capacity up front. So each product, let's say, takes $100 to purchase, and the total purchase quantity is Q. So then the other items are basically same. We're just replacing 400 with Q and making it a decision variable. So now, before we're maximizing P1, P2, P3, and here we're maximizing over P1, P2, P3, and Q. Okay, so quickly about, so this is the previous problem where the quantity is fixed at 400 in the beginning of the selling season, and this is when you make it a decision variable. You also decide how much to purchase in the beginning. So then basically in a solver, you add this item to be one of the decision variables and includes the purchase price into your total profit, and also subject to the constraints that includes this as the capacity limit. So other aspects of this optimization problem are the same as before. All right, so for products with perishability, another tactic to deal with the uncertainty is of possible cancellation later on is to use overbooking. So overbooking happens when we're a seller with a limited capacity and we initially sell more than the total capacity, which is often also a common practice in airline industry. And the basic trade-off is again between wasting capacity because there are a lot of cancellations later on, more than we anticipated, or having a shortage of capacity due to excessive overbooking in the beginning, so that in order to accommodate the little number of cancellations, we'll have to require expensive backups. So in the airline industry, for example, if you booked a flight and then they turns out to not have the number of seats required to accommodate everybody, you're often offered a very high price to go on another flight. So, okay. Let's say P is the price for each unit of the asset, and C is the unit's cost of either producing or ordering or using 1 unit of the asset. And in case of shortage, so not a lot of cancellations and we overbook too much. In case of shortage, then we have incur a backup cost, let's say equal to B. So then we can calculate the marginal cost of having wasted capacity is, say, CW, then this CW is equal to P minus C. And the other side of it is the marginal cost of having a capacity shortage. Let's say CS is equal to
C minus C plus. C minus the backup.
B minus P. And let's say the amount of overbooking is O. And the service level is therefore the probability of having less cancellation than the amount overbooked. The equal to CW divided by CW plus CS. And assuming that cancellation follows a normal distribution, the optimal overbooking level up front is again applying the inverse normal function, normal CDF function, to this S function, S value, given the cancellation, average cancellation rate, and the standard deviation of number of cancellations. So let's assume cancellation, number of cancellations follows normal distribution with mu C and sigma C. Okay, and so this is based on a simple assumption, right? So this is based on a simple assumption. In practice, what is more accurate assumption is that the amount of cancellation is proportional or dependent on how much booking is done in the beginning. Right? The more people who would booked in the beginning, we would expect to see more cancellation later on. So which means the average number of cancellations is a function of L, which is our capacity, and O is the overbooking level. So L plus O is the total booking level. And so this function is actually difficult to solve because it has O on both sides, and it's an implicit function which often, unless we have a very simplistic form of the F inverse function, this would require trial and error to solve. So once we know this formula for overbooking, given the cost of wasted capacity or cost of capacity shortage, we can calculate the optimal S star. And then from this S star, we can make, based on the assumption made, right? If we assume overbooking or cancellation is independent on the initial booking level, then O star can be simply found by using the norm inverse function. Say mu C is 800 and sigma C is 400. Now, the second assumption is, for example, to say how many orders or how should the supplier accept if the cancellation are normally distributed, but the mean is 15% of the total booking, and the coefficient of variance is 0.075. There should be no, this is a typo, there should be no comma there. It's 0.15 times the total booking. So this can only be solved by trial and error. So this optimal overbooking level is easily solved by using the norm inverse function. But this overbooking level is tricky to solve. Basically, we need to calculate the right-hand side of this function. And we use one cell to calculate this function, which is here, and it is a function of the overbooking level by itself. So we need to make sure that this cell and this cell are identical. So this is done by trial and error. You put in different values and narrow down to eventually a value where these two are very close. Okay, any questions? Let's take a break. Okay, so last case that we're discussing on the revenue management is when there is a mixture of markets that we're serving between bulk market and spot market. So the difference between bulk market and spot market is very similar to the differentiated pricing idea as well. So basically, the bulk contracts are long-term contracts where we're selling at wholesale prices, right? So these are generally cheaper than retail prices, and the spot market contract requires us to immediately deliver the product. So there is a very high responsive requirement, but the spot market is willing to pay higher for the product. So the basic trade-off is to between getting a committed demand at a lower price in the bulk contracts versus potentially getting a higher price later on in the spot market. So for the buyer, then the decision is what fraction of the anticipated demand to purchase from the long-term bulk contract. So if we allocate more demand to the long-term bulk contracts, then we might run the risk of running out of capacity for the spot market, which is higher profit margin. Whereas if we reserve more for the bulk market than we are reserve less for the bulk market, then we might run the risk of not incurring sufficient demand from the spot market. So again, the trade-off is we're going to find the balancing point between the two marginal revenue from the spot market versus from the bulk market. So again, let's say if CB is our bulk price, or unit price if under a bulk contract, where CS is the spot market price. And the general assumption is CS should be greater than CB. And let's say Q star is the optimal amount to be purchased in bulk. Then let's also denote this P star is no longer price. Here is we let it equal to the probability that demand from spot market is less than or equal to from Q star, from the bulk market. So the expected marginal cost of reserving more for the spot markets is going to be equal to 1 minus P star. Right, so if demand exceeds what's in the bulk market, the amount to be purchased in the bulk market, then there is leftover to be bought in the spot market. And for each of that market products sold in the spot market, we're going to make CS. And this is the marginal cost for reserving more for the spot market. And this, at the optimal value, this should be equal to CB, the current marginal cost for the bulk item. So solving for P star would give us P star is equal to CS minus CB divided by CS. So then the optimal quantity to reserve for bulk is again applying for the inverse normal CDF function, given that demand, right, so this is equal to CS divided CB divided by CS, and applying the inverse CDF function to both sides will give us Q star should be F inverse P star given the demand distribution. So as an example, if the bulk contract sells at $10,000 per million units and spot market sells for 12,500 per million units, and the demand distribution is on average 10 million units with sigma of 4 million units. And then plugging in the numbers, right, those, so the P star should be equal to 0.2, which will give us the Q star equal to 6.63 million units, and that's what we sell in a bulk market, and the rest is sold in spot market. So this is how we design a portfolio between bulk versus spot market when there is a differentiated pricing and differentiated delivery between the different markets.
6.63 million units will be bulk, or 6.63 percentage of.
Mm-hmm.
No, whether it will be a quantifiable, whether it is 6.63 million units or 6.63 percentage
Million units.
Quantity.
quantity.
Okay, so finally, some things to be careful for when using revenue management. So we all know, you've probably heard of the high-profile case for United Airlines when they did the overbooking of their flight, and then they physically forced the customer to deboard the aircraft, and it became a very high-profile case. And then because of it, the CEO of United Airlines came to apologize, and they adjusted their penalty for being overbooking for their customers. They significantly increased the compensation for their customers, and so it's the reasons why that was such a high-profile case. Not only because it's not right for them to use physical force on their customer, but also because they the overbooking issue. Right? They did not anticipate the behavior of customers correctly. So when there is not sufficient cancellation, they assume that people will be willing to board another airplane given their current compensation, but the fact turned out to be false. So then in order to deal with it, they had to adjust the compensation level to more correctly represent the real customer behavior. So the customer preference must be really well understood under revenue management. And so the revenue management should be aimed at improving service for all customer segments, especially the most valuable segment of customers. And these different segments have placed different values on different attributes, dimensions of the product. And these dimensions should be clearly communicated to our sales force and operations team so they can prepare and respond appropriately when we do face negative outcomes from the customers. And it's also very important to communicate these dimensions or values we provide for customers. You know, whether it's fast delivery for customers who value, you know, fast response, or some other dimensions of service. It's important to inform the customers that these dimensions are there and they are appropriately differentiated in our revenue management profile. And also, one can be easily tempted to implement a very highly complex revenue management scheme because there are just so many decision variables that we can potentially tweak, and if we include more, theoretically speaking, we can achieve better results. But there are exponentially increasing effort costs when we increase the complexity of our revenue management scheme. So if any additional decision variable do not add significant value, we should really avoid adding them. So for the last topic of this course, I want to end it on the, you can say, emerging issue of supply chain management, which is sustainability. Right, so it's important to understand the importance of sustainability and what are the challenges posed against sustainability. How are corporate social responsibility valued, and what are the opportunities out there to improve sustainability, and what are the roles of various government incentives and regulations for improving sustainability. So as supply chains are becoming more and more globalized, and the emerging countries have grown, it has becoming more and more clear that our resources and environments will not be able to support this growth unless our supply chains become more sustainable. And besides the need to make the world more sustainable, the increased focus on sustainability can also allow our supply chains to reduce risk, become more efficient, and attract some segments of customers. And we see a lot of sustainable development these days that basically require economic developments that meets the needs without compromising the ability for future generations to meet their needs. And we see a lot of different initiatives from industry segments. For example, Walmart has long implemented their sustainability index program So they extensively work with their suppliers to encourage their suppliers and all their supply chain members to implement a certain set of sustainability strategy. And we see this more and more today in a lot of different companies, countries, regions, from different sets of motivations. So the United Nations have defined the pillars for sustainable development. So one, it deals with economic sustainability. So which is what we had been focusing on in the traditional economy. And the added pillar are environmental sustainability, right? So things dealing with the natural resources and interaction with our natural environment. And then we also have the pillar for social sustainability, where we deal with the human aspects of our economics and industry. So in principle, all three pillars has to be reconciled in order for sustainability to occur. And what are the factors that encourage more sustainability within our industry? The one that we see most is reducing risk and improving financial performance of the supply chain. And secondly, we also see communities and governments that puts pressures on the industry or introduce incentives and mandates, policies to help the industry regulate itself. And lastly, we're attracting customers that value sustainability. So in traditionally, the majority of efforts to improve sustainability is motivated by financial reasons. So in fact, a lot of sustainability initiatives, such as reducing emissions, reducing resource inputs, are actually consistent with financial drives. So there are studies that show that such sustainability initiatives actually are most of the time cost saving as well. And that can be seen because a lot of times it saves energy, and energy is costly. And in the past decades, governments and regulatory bodies have introduced various kinds of policies and regulations to mandate industries to put sustainability on a higher priority. And from the customer side, the book says we're seeing very few initiatives from customers who voluntarily value sustainability and are willing to pay more for sustainability. But actually, since it's a topic that's very dear to my heart, so there's actually a lot of research evidence that people are actually willing to pay significantly higher for green certified products, more sustainable products, and that premium is becoming higher and higher. The captured customers are becoming more and more, and the categories of products are also increasing. So one thing that impedes sustainability initiatives is the potential high upfront investment that it requires. So for example, if we want to switch our energy consumption from fossil fuels to solar panels, that might require a large upfront investment to install solar panels. Although a lot of these upfront investment will prove to be actually more cost efficient in the long run. And so some of the barriers to increase the focus on sustainability are, one is potential insufficient return on investment, or customers are reluctant to pay a premium, or that the evaluation of sustainability itself is a difficult task because it requires you delve into a whole life cycle analysis of the products from the beginning of the raw material to maybe even consumption. So why do we need to talk about various strategies to deal with sustainability issues? It can be explained by the tragedy of the commons, which is an economic concept. So we're referring to the dilemma when the common goods does not align with the good of individual entities. Or does not align with the good of every individual entities. So in the case of our supply chain, because the supply chains operate on a global level, the impact, the cost of the supply chain may be incurred by the firm itself locally, but the effect it has on the environment, on a social level, are global. So a disregard for sustainability is the benefit from sustainability is shared among parties globally, and the cost of disregarding sustainability issue is also lessened by being shared with everyone else. And so because of this tragedy of the commons reason, generally we cannot achieve a good solution to sustainability on a global level without some kind of intervention. So what are some solutions? One is, as the tragedy of the common guy says, we need to choose from options that are unlikely to be supported by all of their own will. Right, so the overall best sustainable solution probably will harm the freedom or the benefits of some individuals. So it is important to choose from options that are actually not benefiting everybody. And this can be done by this strategy called mutual coercion, which is to say we use either social arrangements or other mechanism to coerce all the participants in a way that helps the common good. And this, on the grand level, can only be implemented in some kind of national, global, or regional policy. So one way to do that is the command and control approach. where we have government or regulators set a hard standard that you cannot violate. So, for example, fuel efficiency standards require, new cars that are produced should satisfy at least some level of fuel efficiency. Otherwise, they cannot be manufactured. And command and control approach tend to be inflexible, and they are also not always cost effective. So a more cost-effective mechanism are market mechanisms, and this has been, widely implemented for, emission policies. For example, we have the, European Union cap and trade market, where you basically have a certain allowance on the overall emissions to be allowed on the total industry, and then each company would receive some allowance. If you emit under this allowance, you can sell the leftover allowance on the market. If you emit over this allowance, then you will have to buy from the market. Right? So under cap and trade, you create a limited number of emission allowances, so the total emission is capped at a certain level. Whereas the other approach is carbon taxes or emission taxes. So basically, it's operated under the principle that polluters pay. Companies pay proportionally amount of money to the amount of emissions they emit. So we also talk about corporate social responsibility, which are also evaluated at the 3 pillars established by the UN. So we talk about environmental responsibility and social responsibility, and then governance. And so to implement corporate social responsibility, there are 2 fundamental challenges. One is the scope of measurement. So how much of environmental impact are we including in evaluating the company? Same as social. And also, what kind of measure units do we use? Are we talking about the total consumption of energy, for example, or are we talking about consumption of energy per unit of product produced? So these would, give different evaluations for a certain company depending on which measure we choose. In terms of in governing the environmental pillar, we look at the firm's impact on environmental aspects, the air, land, water, and other ecosystems. And we look at, possible efforts for reducing resource consumption, for reducing emissions through the process and through product innovation. So through resource reduction, the company can achieve a more efficient use of natural resources in the supply chain. So you can also see this as more of a input during the process and output fashion. The emission reduction part deals with the impact of emissions, waste, or water discharges, or an environment impacts of the company. in the community that the company is affecting. And product innovation reflects the government's ability to reduce the environmental costs and burdens for its customers through some development of eco-efficient products or services. So for example, LED light bulbs would be a product innovation that GE or some other company are implementing, which is also corporate social responsibility that is achieved as an environmental positive impact through the consumption of customers. Another thing to notice in terms of environmental aspects is that a lot of times companies make invalid green claims, right? So we call it greenwashing. A lot of labels and claims that companies place on their product are oftentimes actually intended to capture more profits, but not carrying any substantial meaning to actually improving sustainability. The social pillar of corporate social responsibility is related to the human aspect. So dealing with workforce, labor laws, customers, how we treat customers, and the society as a whole. So the social pillar, because the supply chain now deals with visibility issues and suppliers and customers that are in other countries. So in order to enforce the social pillar, it's important to do audits of suppliers and trainings and development programs for suppliers. And so collaboratively build capability with suppliers to improve their performance and lower their operating cost. And the benefits will be accrued to all the customers of the supplier. So of course it is also an issue of tragedy of the commons. So generally, big companies, they would do this because they're at an advantage of implementing these audit services and running these support programs. And then the government's pillar focuses on the company's government style to execute its business based on management practices and organizational behavior involving their board structure, their compensation policy, shareholder rights, vision, strategy, and so on and so forth. And the general requirement is that the vision strategy for the social and environmental aspects should be also aligned with their economic performance for it to be more practical. And a lot of times we see companies list their visions of their grand picture on sustainability, environmental responsibility, but usually these visions are easy to state but very hard to implement. So before we talked about different drivers of supply chain that improves the profitability of the supply chain. So we talked about, capacity, inventory, transportation, sourcing, pricing. And all of these drivers will also have an impact on sustainability and social aspects. So one is facilities. So facility is actually a very large consumption point for energy, for water, and it also generates a lot of waste and emissions. And so successful companies, what they do are they separate the improvement opportunities to those that generate positive cash flows. So it also helps with the economic aspects and those that do not. And then they start with implementing the profitable projects first and then deal with the higher hanging fruits later. And facilities often provides the highest possibility for improving, environmental and financial performances through innovation. So one example is Coca-Cola, who made innovation to reuse their heat energy from the boilers in their production and reduce its total water footprint. From the inventory perspective, if we want to consider the aspect of sustainability, it requires us to look at inventory from, a cradle to grave point of view, and include landfill inventory also as a part of the company's inventory. So, and the landfill inventory may not show up traditionally on a firm's balance sheet, but it is one of the most damaging aspects from a sustainability perspective, and the cost is borne collectively by the society. So then we can use life cycle assessment, for example, to evaluate the environmental impacts associated with the different stages of the product life, different kinds of inventory, and the goal is to reduce the most harmful portions of the inventory and also unlock any unused value at the end of the product's life cycle. So one important suggestion is to use cradle-to-cradle design. So basically, the design of the product should take into account of possible remanufacturing process or recycling process or disposal process at the end of the product's life cycle. The goal is either the product's design is the component of the product is very easy to dissolve and cause very little harm to the environment, or the product's component can be very easily and efficiently reused or recycled in the production process. In terms of transportation, the one improvement of sustainability through transportation is through reducing resources and emissions. So basically reduce fuel consumption and then reduce the emission and waste generated from consuming the fuel. So this can be done by, design more fuel efficient, vehicles, or design less emission intensive fuels, or design, alternative fuel vehicles, electric vehicles, and so on. But in addition to the fuel and the vehicle itself, the product design can also play a significant role, right? So that determines how efficiently we can use the capacity of a vehicle. For instance, IKEA has these very flat design for their product, which allows them to very efficiently stack products into their trucks, very high utilization of their truck capacity. So each unit of product would have a significant lower emissions associated with it. In terms of sourcing strategies, from the company's perspective, the social and environmental impacts often occur in the extended supply chain rather than the firm itself. And as the supply chains extends longer and longer, the impacts also have grown to impact, other communities in the world. And so it became a very challenging task to keep verifying what the suppliers are doing. Are they complying with, for example, labor standards? Are they complying with environmental regulations? So verifying and tracking their performance and becomes a major challenge for companies. In terms of pricing, we just talked about differential pricing. And differential pricing is an important lever to reduce, to improve the utilization of assets. So, for example, in airlines, right, if we were to use differential pricing, we might be able to fill each airplane to a full extent. And the number of people in each airplane has very little effect on the total emissions or fuel consumption for the airplane. So each individual person then is corresponding to a much lower emission level if we were able to utilize the airplanes more efficiently. If the visibility, consumption visibility could lead to reduced resource consumption, and this happens if, for example, the visibility is simultaneously coupled with lower price products in the off-peak demand cycle, then there is a potential to reduce peak load demand by pricing strategically, use dynamic pricing, for example. Again, the challenge is to actually change the customer's behavior, customer evaluation for sustainability. Increase their willingness to pay if the product or service is more sustainable. And the government incentives can also be implemented to encourage customers and firms to purchase sustainable products. So, for example, subsidies for electric vehicles is often, an incentive for encouraging the consumption of electric versus fossil fuel vehicles. So again, because of tragedy of commons, we do need any outside incentive or regulations in order for people to behave sustainably, to choose sustainable decisions. So a lot of the incentive or regulations or policies are aimed at putting a monetary value on the social or environmental impact of companies or individuals' actions. And so for example, placing a price on carbon emissions is or so-called emission tax is what the governments are doing by translating the cost of emissions on the society to monetary terms so that firms can directly account for them when they're making their production or other decisions. In terms of other solutions, so one important aspect of supply chain is now the increasingly used term of closed loop supply chain. So basically, we're closing a loop between the end of product life cycle with the beginning of the product life cycle through recycling and remanufacturing. And the extent to which the supply chain can recycle or remanufacture depends on, one is the incentive created to the manufacturer. So, for example, there are government policies like take-back mandates, which could say, you have to recycle a certain percentage of your product, or remanufacture a certain percentage of manufacture. And there are, deposit refund programs that are create an incentive for customers to recycle their product, and subsidy incentives for manufacturers to remanufacture their products. Another consideration for remanufactured products is it could potentially cannibalize the demand of new products, which is disincentive for companies to remanufacture or recycle their components. In terms of the emission pricing, again, it's along the logic of tragedy of the commons. So we need a regulating policy to monetize the cost of emissions. And the two approaches to achieve that is a carbon tax or a cap and trade system. The key challenge in carbon tax is to set the appropriate tax rate. The decision in cap and trade is to set the overall allowance. So some considerations in pricing emissions are, one is how much does it cost to administer this mechanism, whether it's a carbon tax policy or the trading of emission allowances. And price volatility, so carbon tax is a fixed price, whereas in cap and trade, you see the price would adjust as the market changes. So you would see a lot more price volatility under cap and trade, which could discourage company from participating. And then emission uncertainty. So cap and trade creates a cap on the total emissions emitted, but carbon tax has no such guarantee. New information uncertainty. So there could be, anytime in the future, there could be a new technology. There could be a more efficient way of reducing emissions. So these could lead to different costs for companies to reduce their emissions and change the pricing policy. And industry competitiveness is another consideration. So by imposing a price on companies for their emissions, that could potentially reduce their competitiveness. And when this, what this does is potentially hurts its own emission-intensive firms and favor, firms from other countries who are not subject to these policies. And similar to that, we may have wealth transfer to energy exporting countries. So, which is, for example, the issue of carbon leakage is when companies being subject to a very strict emission policy would move their factories and production to other countries without such a strict policy. So then the wealth, along with other things, are exported to other countries. And finally, studies have shown that the cost of emission pricing policies are minimized if any government revenue from these policies is returned to the customer, either in a form of reduction in pre-existing income or sales tax. All right, that's all. I'll see you next week for our last case study. So we won't have another homework. I'll post some exercise problems and solutions related to today's lecture. Yeah.